All right, so I'm going to just record. So this way I don't need the internet access, so I don't have to reset everything. And then for the student who's online, I am going to use a voice channel. So this way, the student can hear me. Okay. And then do a screen share. There we go. All right. Okay, so looks like, we can do that now. Cool. Okay, there we go. All right, so getting back to this U is union. So what we are looking for is, I want to choose A, B, and C somehow so that E is A union B, H is the union of A, B, and C, as three sets. And we want E to be found as in X. We want H to be found in H. And let's see, we also want A to be found in H because A is also the first of a two tuple in F. All right, in other words, I'm collecting most of the concepts that we have talked about in this class up to functions and make a stir fry out of them. All right, so what is the answer? First of all, can you identify A, E, and H? Can you identify out of, okay, let me get back to the editor. So can you identify A, which is a set, E, which is a superset of A, it contains some additional stuff, and can you also identify H, which is a superset of E, which means it contains even more additional items. All right, so let me just kind of do this so that everything lines up a little bit better. It's easier to read this way. All right, so now we want to look at this and find out is there a two-tier relationship of a subset over here? Something is a subset of something else, and then something else is also a subset of the second item. If that is the case, how would you organize? Which one is A, which one is E, and which one is H? Yep, go ahead.
I think A is either the set of one or the set of three,
Uh-huh,
and then E would be the set of four, one, and three,
uh-huh.
and then H is the
H
set
is
with
the biggest one,
Yeah.
right? Okay, that makes sense. Okay, so that answer makes a lot of sense. So, but the question is not asking for, oops, that went away again. But the question is not asking about, which one is A, E, and H, but we'll figure out the A, B, C later on. So now we'll say A is the smallest one, which is just one. E is the next one up, which is 4, 1, 3. And then H is the next one up, which is 4, 5, 3, 2, 6, 1, like so. Okay, now that we have identified A, E, and H, can we find the sets A, B, and C? In other words, can we express E as A union with something else, and then express H as E union with yet another subset, another set? Yep.
Wait, how do you know A, E, and H? What did you think?
Well, I'll see if, does anyone want to explain that before I go ahead and explain it? It's basically really just looking at the 5 elements and ask, which one is a proper subset of something, and that something in return is also a proper subset of something else. So you're looking for that subset relationship amongst the 5 items within X. So at that point, it's really just kind of visually recognizing that, oh, 413, is a superset of the set of just one, and then the set of 453261 is, 413 is a proper subset of the set that has 453261.
Oh, okay.
So a part of that is kind of visually scanning, so there's no, actual algorithm to do it other than just kind of visually searching for something like that. All right. So now we can now say what is B? B is basically E minus A. Because remember the minus operator, what does that do? If I say E minus A, the resulting set is going to be, what characteristic does it have? What elements is going to be in E minus A? Yeah, go ahead.
Instead of E without the elements of A.
Everything in E, but not in A. Okay, so very good. So we look at the E set, which is 413. We look at A, it has just one. So that means 43 should be in B. And then we look at C, kind of the same thing, but C is going to be H minus E. In other words, we are asking what is in H that is not in, oh, I do a double curly brace here. That would be incorrect. There we go. So we are asking what is in H but not in E, and that would be 5, 2, and 6. That would be the answer for A, B, and C for this question.
I think you missed five, 2, and 5.
Oh, 5. Okay, sorry. Go ahead.
We also reuse that as 2, 5, 6.
Hmm?
Just so it lines up with one of the sets.
Okay, let me fix this one first. So I know 5 is right, 2 is right, and then 6, right? Okay, sorry, go ahead.
It's just 5, 2, 6 is also 2, 5, 6.
Yes.
So it look better if it's 2, 5, 6.
Oh, if you want to sort everything, that's fine too. It makes it easy to find the items if you sort everything. Because in the set, it doesn't really matter how you write, the ordering within the curly braces is insignificant. So you can write it in any order you want. So you're correct. If it makes it easier for you to look at it and verify the answer, you can change the ordering of the numbers within the set notation. All right. And then there's more, right? So after this, the question asks what is D? D is H minus A union with C. So what do we know about A union with C? We know what is A. A is just having the element of 1. C has the elements of 5, 2, and 6. So H minus the union of A and C is going to be everything in H that is not 1, 2, 5, or 6. So 3 and 4. Yep, that is correct. That's right. You can see how with one single question with many different parts, I'm testing you on most of the concepts that we have talked about in this class. All right, what about H here? To create a new set H so that it is F union with this new member here. Okay, so when you have a union, you cannot union with a single element. So that's why you need to use a set notation to make sure that you end up with a set first. Okay. So now let's try to answer the question. First of all, we want to know what is H. So H is whatever F has, and I'm not too concerned about whatever F has. So I'm more concerned about the other side. What tuple am I going to create here? The first item of the 2 tuple is D, which we just figured out a little bit earlier. It only has the elements of 3 and 4. So that's the easy part. So we got the set which only contains 3 and 4. What about the second item of the 2 tuple? The second item of the 2 tuple is an actual arithmetic expression. It's asking what is f of h minus the sum of f of a and minus c. That's basically what we're looking for. Okay, first thing first, what is f of h? How do I know what is f of h? Tack, you never define what is f of h. Yes?
It's the y value corresponding to that h. So h is 3, 4. So
No, h is, oh, you're right. H is, no, f of h, h is not 3, 4. H is this one here. So h is actually, oh, okay, I was using the pointer in the wrong window. Let me get back to here. There we go. So H is actually 4, 5, 3, 2, 6, 1.
Okay, so it corresponds to the second element.
So it corresponds to 63. Yep. So that 63 is f of H. And then f of A is basically it's 1. And then f of C, okay, what is C again? C is 5, 2, 6. And 5, 2, 6 is 2, 5, 6, and that's 50. So we have 63 minus 50 plus 1, and that will give us, what, 12, I think? Right? 63 minus 51 is 12. Yep. So we have, so that is the new set H. It's basically the same as F, but we have one additional element, which is this element here. Yep.
You should also use plus for disjunction.
There is no such operator defined to add an element to a set. So with the notations that we have talked about in this class, the only way to quote unquote add an element to a set is to use union. But union can only operate between two sets. And that's why we have to create what I would call a singleton set, because it has one and only one element. So we have to create this set so that we can use the union operator. All right. And that answers the question of what is H. And now it's asking create a set V, blah, blah, blah. So this part is really the same thing as before, where V is what is considered X earlier, W is what is considered Y earlier, and then P of H, V, W is going to be true. And then the question is it a function? If it is a function, is it injective? The answer is yes, it is injective. And then the second question is, if it is not injective, why it is not? So, the last one does not apply because it is indeed an injection. All right, so any questions about this particular question? Any comment other than it takes longer to read the question itself than to answer it? Maybe. Yep. Mm-hmm.
Can you show what the set H was again?
Sure.
The one.
I don't want to put the answer in the test here because I want you guys to have a blank test to kind of practice on. So in here, H is basically 1, 2, 3, 4, 5, 6.
I meant the small H.
The small h. So the small h is going to be whatever f is defined to be, which is kind of long and kind of cumbersome to copy,
Yeah.
and then plus this particular one. Yeah. So if you want the actual representation, I can do that too. So basically, what we do is we take whatever f is and copy paste it here, and then just add the new tuple that we constructed earlier, which is this one. That's the only new element that we are going to put in here. That's it. So that's the complete actual h, lowercase h. All right.
I don't think we're gonna have enough time to complete this.
But why is that the case? Why do you think we don't have enough time? So I think that question might stem from not, okay, first of all, are we familiar with the symbols? Are we familiar with the notations? That would be the first thing, right? And then the second thing is to basically, I think the most difficult part is really just to figure out how do we solve for A, B, and C. But to solve for A, B, and C, we have to first figure out what is E and what is H. So from here, we know that A, E, and H, they are all elements from the domain. So each one is basically a set. And then when we look at this, E is the union of A and B, then we know E is a superset of A. A is a proper subset of E. When we look at this, we know H is containing additional items. So that means E is a proper subset of H. So at that point, the biggest puzzle is solved because at that point we know A is a proper subset of E and E is a proper subset of H. We just have to look through all the things in uppercase X, the set, and identify the three sets that we need to become A, E, and H. Once we figure out A, E, H, then we can figure out what B and C are, because B is basically the difference between E and A, and C is the difference between H and E. So at that point, we have solved for A, B, C, and D is pretty easy to figure out because we just have to discount everything in A union C from H, and that becomes D. And once we know D, we can now figure out the H, which has one additional two tuple. That one additional two tuple is constructed using this expression here. We know what D is already. We just have to apply f of H, which is basically asking, what is the second item next to H? And what is the second item next to A? What is the second item next to C? Perform basic arithmetic operations. That gives us the value that is associated with D. Yep.
For the sections that say explain, do you need segmentation or can we just like?
You mean if H is not injective, then you have to tell me why it is not injective. So what do you think is the best way to explain why H is not injective? Now this one is injective, so it doesn't apply, but let's just say that H is not injective. What would be an evidence that H is not injective?
Elements of the codomain not to more than one.
Correct. So you have two things from the domain mapping to the same thing in the codomain. And that will be what you explain here. You can basically say this value and this value from the domain, they both map to the same thing in the codomain. And there are many ways to phrase it. So how you phrase it is not important, but knowing that you know what makes a function injective and what makes it not injective is important. All right. Are we okay so far? Yep.
Can I see the answers one more time?
Sure. Mm-hmm.
For this question, answering in this format, like similar to what you have here, is it enough or is
It is enough.
it is enough?
Mm-hmm. None of this is asking for an explanation.
Okay, so only when you ask for it.
Yeah. Only if there are steps that you need to
Unless
show.
there's that,
Yeah. So the only place where there is a real step that you need to perform is how you figure out A, B, and C. Because to figure out A, B, and C, you have to first find what is A, E, and H. And then B is the difference between it's E minus A, and then C is H minus E. So that would be the only potential place for any explanation. But in this case, I'm not asking for explanation. All right. Okay, so moving on to the second one. More nightmares like that. But same format, slightly different, okay? So this one is slightly different. It is basically, what are we trying to figure out? This one is trying to figure out A, B, and C too. But the way we try to define the new element is different. So this time it is f of h divided by the product of f of a times f of c, but otherwise same structure. So I'm going to skip this one to go to the next one because the next one is not having the same characteristic. Okay, because the only difference between this one versus the one earlier is what do we do to create the new element in H? And instead of using subtraction and addition, this time we're using multiplication and division. So it's not too big of a difference compared to the previous one. If we have enough time, we can get back to this one. So now we move on to question number 3. Oh, I like question number 3. I think some of you are liking it already, just reading the question. Okay, this is question number 2, and here's question number 3. So the first part of question number 3 looks kind of the same as question number 1, where we want to extract the first item of every set, to be X, and we want to extract every second item of the two tuples to become Y. And once again, we have an actual function. So to answer this really quickly, okay, let me go back to here. And I'll just go ahead and answer the first part really quickly. This is for question number 3. X is a set of all of the items, the first item of every two tuple. So it's going to be 3, 4, 6. Okay. Some of you are saying, okay, can we just look at it sorted? Yes. Okay, fine. We'll just look at everything sorted. And then 5, finally, like that. Yep. So that's going to be X, and then Y is going to be 12, 58, 17, and 16. There we go. And then P1 of f, x, y is true. Okay, so that's the first part. The first part is almost trivial. And then now we need to look at the second part, which I think is where the puzzle is. So now we'll go ahead and read the second part. So the second part is specifying the constraints again. First of all, A is the first item of a two tuple, so is B, and so is C. So that's the first constraint that we know about A, B, and C. And then we have some additional constraints. So the additional constraints is A cannot be the same as B, A cannot be the same as C, B cannot be the same as C. Okay, that's just a really clumsy way to say that they cannot, none of the three can be the same as one of the other. Okay? And what else? Well, this time it's a little bit harder. We have a negation. So we basically are saying A cannot be a subset of B, and B cannot be a subset of A, and C is an intersection between A and B. All right? So the first part is basically saying, note they are all different. A, B, and C are different sets. The second part is saying A and B cannot be subsets of each other. Okay? And then the third part is really the most important part, which is C is the intersection between A and B. Now, why do I need all of these constraints? Because without these constraints, A, B, and C can be the same thing. If A, B, and C are exactly the same thing, without the earlier constraint here, it's very easy to find C, because C is really the same as A and B, because if you take a set and you ask for the intersection of itself, it's the same thing. So I just did not want the answer to be trivial to ask this question. All right, so what do you want A, B, and C to be? We want them to be different, but we want C to be the intersection of A and B. So you look at all the items in set X. You look at each element, which is by itself a set, and you ask, is one of these the intersection of two of the others? So what do you think?
So here's 1, 5, 5, and then 2, 5, 6.
Yep, that's right. So 5 is in the intersection of 2, 5, 6 as a set, and 1, 5 as a set. So yep, so you got it. So which one you want to call A, which one you want to call B, doesn't matter. Because intersection is commutative, which means, the left and right, they can swap. All right, so now we know the answer of what is A. A is, I'm just going to read from left to right. So A is 2, 5, 6. B is 1, 5. And then C, which is the intersection, is just the set of 5. Very good. Okay. So now we look at D. D this time is the difference of A minus B. Whatever is in A that is not in B. So what would that be? We need things that are, sorry? 2 and 6. Yes, that is correct. Because 5 is common to C and A and B, sorry. All right, moving on to H. So H is basically F union with a set of only one new two tuple. And the first item is D. We know what D is, which is 2, 6. And then the second item is f of A minus f of B. F of A is the application of the function f using A as an argument, which means we're really just looking for the second item corresponding to 256. So 256, it has a number of 50 next to it. And then when we look at B, which is 15, it has 17 next to it. So we are basically really looking for 50 minus 17. And that turns out to be 33. So there we go. Are we okay so far? Okay. And if we read the question, the last part is the same as for every single question. So B is kind of like X, except it has one extra element now. W is kind of like Y, but it also has a new element now because we have one new two tuple. P1 of HVW is true, so we still end up with a function. This function is bigger than before. It has a slightly bigger domain and a slightly bigger codomain. F is a function, so now the question is it injective? In other words, we're really asking, did anything map to 33 before? I do not believe so, but let's go ahead and double check. All right, so you look at all of these things, or you just look at the set Y and you ask, is 33 in Y? The answer is no. So we still have an injective function. So the answer to is if H is a function, it is. Is it injective? The answer is yes, it is injective. All right, are we doing okay so far with question number 3? So once you work out the first question, because the format is almost the same across all the different questions, it goes a lot faster after that. At least with the exam from last semester. This is question number 4. And question number 4 is different from the previous question, so we'll work this one out too. All right, so this time, x, y, same deal. X has the set of 3, 4, the set of 6, the set of 1, 6, the set of 2, 3, 4, 5, and the set of 5. Okay, so that's basically what the set of x is. The set of y has the element of 35, 13, 26, 1,155, and 11. And then P1 of fxy is true. In other words, this is indeed a function if you consider how we define x to be the domain and how we define y to be the codomain. So that portion is kind of the same, okay? Structurally speaking, it has not changed. This part should be answered only if f is a function. It is a function. We'll find set C, D, and E such that C, D, and E has to meet these requirements. And also for some A, B, C is the union of A and B, D is the difference between A and B, E is the difference between B and A and B cannot be the same, A and B cannot be subsets of each other. Okay, so based on these constraints, how do we get started? Where do we start, right? There are all kinds of symbols being thrown around. So the first thing we know is C, D, and E, they have to be elements of X. That's the first constraint, okay? So now we can just focus on all the elements of X or all the first item of the two tuples in the original F. So that's where we start. And then we look at the constraints, okay? We look at the constraint that we have to somehow find sets A and B. So sets A and B, each one, does not have to be the first item of a two tuple. There's no such requirement for A or B. But we do have the extra requirement that C has to be expressible as the union between A and B. D has to be expressible as everything in A but not in B. And E also has to be expressible as everything in B but not in A. A and B cannot be the same, and A and B cannot be subsets of each other. Okay, so now how do we find those 3 sets, C, D, and E, as the first item of each two tuple to satisfy this requirement? So one is going to be the union. The one that is the union, probably is the bigger one, right? It's going to be the one that has more elements. So now we look at, all of the first item of the two tuples of the original set. We go like, I have a strong suspicion that 2, 3, 4, 5 is the biggest set. So the chances that it is our set C here is the highest. Okay? So if that is the case, then I have to find something D such that I have to find set A and B so that D is the difference between that. Okay, if you know that C is A union B and D is A minus B, what can you do to relate C and D? Because that is going to be a big clue to us, is when we find out how C and D are related. I'll give you a hint. Is one a subset of the other one between C and D? D is a subset of D. Very good. What about E? E is everything in B, but that is not in A. How does E relate to C? E is also a subset of C, right? So now we know what we're looking for is we are trying to look for three things in the set of X, which basically are the collection of the first item of each two tuple in F. And we're looking for three things such that one is the superset of the other two. And then the other two cannot be the same. Okay, so you look at all the things in the set and you ask, can we find, okay, let me just kind of type it out first because I think that makes it easier to read. So this is for question number 4. X is 3, 4, 6, 1, 6, 2, 3, 4, 5, and 5. There we go. All right, so looking at that, can you identify one thing in here that is the superset of two other things? And then those two other things cannot be the same. All right. So we look at 2, 3, 4, 5. 3, 4 is a subset of 2, 3, 4, 5. But 2, 5 itself, is not, present as a set. So that cannot be the answer. Let's see. We have 3, 4. Okay, did I copy anything wrong? Nope, I did not copy anything wrong. So C is the union, D is A minus B, and then E is B minus A. D and E are both found in the set. We got 3, 4, we got 6, 1, 6, 2, 3, 4, 5, and 5. So I got all of those correct. Okay, let me just read the constraint one more time because I think I have a solution, but it's not a very friendly solution. I'll explain why I say it is not a friendly solution. All right, so let's say that C is 1, 6. And we are going to make, nope, okay, A minus B. It's got to be a solution. Okay, I just need to work this out. Okay, C, D, and E are found in X. A and B are something else that's floating around. So we know that D is a proper subset of C. Okay, so let's examine that one first. D is a subset of C. Okay, does that make sense to you? Why does it make sense? Because everything in D has to be in A, right? We just have to exclude something in B, but the entire A can be found in C. So that basically, intuitively, we know that D is a subset of C, and the same thing for E. E is also a subset of C. So we are looking for two different sets that are subsets of the same set within these 5 items here. So the 3, 4 is easy, right? The 3, 4, we can see it this way, but I cannot find something else to meet the other requirement.
My help is finding B usually out, right?
But we have to find C, D, and E first. So we have to first find the candidates for C, D, and E, where D is a proper subset of C, and E is also a proper subset of C.
So 3, 4, and 5. So the set of 3, 4 is a subset of our proposed C, and then 5 is also a proper subset of the proposed C. So in a way, we have a candidate for E and B, we just don't know which. 3, 4, and then the set of
Okay.
5 is
All right, so
potentially B and D.
So let's check that out. And so we know that E is a subset of C. So we want C to be 2, 3, 4, 5. And then we can make D 3, 4. And then we can make E, let's see, the only thing left is 5. Okay. So the 2 is not anywhere. All right, so let's see if we can make this work. So now we have to find out what can be A and what can be B. All right. So we want A union B to be 2, 3, 4, 5. We want A minus, we want D to be A minus B. So D needs to be A minus, D needs to be A minus B. And then we want E to be B minus A. All right. Okay, D is 3, 4. So everything in A but not in B needs to be in D. So we know A has to have everything that is in D, which is 3, 4. So we know that much has to be in A, and then B needs to have at least 5. All right. And now we're missing one more thing. The 2 is missing because when you look at the union between A and B, the 2 is missing. So the question is, where can we put that 2? They just have to be in both because the subtraction says it cannot be in both. So I think that's the solution. But the steps are there, okay? So the reasoning is already there. We figure out, what is C, what is D, what is E, because we know D is a subset of C, we know E is a subset of C, and then we look at A, B, and ask, what needs to be in D, or what needs to be in A, and then we ask what needs to be in B, and then we come up with a minimum set for A and B, but it's still not accounting for the 2, because the 2 needs to be in the union between A and B. But we know that the relationship, the way we constrain A and B, is only by a subtraction. So that means a common element between A and B would not show up in D nor E, and that turns out to be our 2.
For this question, does
Mhm.
it matter if we assign which set is
It would
B
not
and
matter.
E? It's just different answer.
Yeah, A and B are symmetric, and so is D and E. Those two are symmetric too. But you're not even asked, about what is D and what is E. As part of your steps to find out what is A and B, D and E are important. You need to know what D and E are supposed to be, but the actual answer only is about A and B.
Yeah, but then with that, if I say D is the set of 5 and then E is the set of 3, 4, because it's still technically, well,
Say that one more time.
if I just flip the assignment,
Yeah, you can switch between these two, right?
yeah,
Yeah, you can switch between these two. If you switch between those two, I believe you have to switch between those two too.
yeah, okay,
Yeah.
then that's fine.
Yeah, because there's a certain direction associated with the which way you're subtracting. So if you switch, what we see here as D and E, then you will also have to switch what we see here as A and B. All right. So that's problem solving. Okay. Are we okay with this? Now, which part of the exam relates to the material that we have taught in this class, and which part of the exam question does not relate, which is basically the application of logic. So what do you think? Okay, let me go back to here. If I just look at this, okay, forget about the answer, okay, we'll just focus here. If C is the union of A and B, and D is A minus B, just because of this, I can tell that D is a subset of C. But does that make sense to you? Yeah? Okay. So that's one thing that that's based on the definition of what is a union and what is the definition of the difference between two sets. You basically make an inference, and now you say, okay, given this is how C is defined and this is how D is defined, we now know that D is a subset of C. And we, using the same reasoning, we can now say E is a subset of C. That really helps to find, okay, what can be C and D and what can be E. Once you constrain that, okay, once you say, okay, I think C is this and D is this and then E is this, there are only so many things you can choose because C, D, and E, they all have to appear as the first item of a two tuple in F. So you only got 5 choices to begin with, right? And then knowing that one is the superset of the other two, that's probably the set that has the most elements. And then you just have to ask, okay, what other two sets are proper subsets of the one that is the biggest? So it doesn't take too long to find those. Once we have identified what is C, D, and E, then we have to work out what is A and what is B. The way we work out what is A and what is B is D has to contain everything in A, but not in B. So that basically means that A must have whatever is in D, so that means 3 and 4 has to be in A. And using a similar reasoning, we now know that B has to contain everything that is in E, and E has the element of 5. So 3, 4 in A has to be the case. Okay, there's no two way about that. 5 has to be in B, same thing. So those are the constraints. And then when you do the union between A and B, having only 3, 4 in A and 5 in B, then you find out that, we cannot address C because C also has an extra element of 2. So the question is, how do we introduce the element of 2 in C and still be meeting the constraints of D equals to A minus B and E equals to B minus A? And then you remember, the subtraction thing means something that is on this side, but not on the other side. So if something is common between B and A, it would not show up in E. And likewise, it would not show up in D either. That's the element of 2. So that's how we added the element of 2 to both A and B, and now they satisfy all the constraints. So that is basically how I work this out step by step in my mind. And the answer is no, in case someone is suspecting that, I actually took the time to prep for this class and actually worked out all the solutions ahead of time. No, I did not actually do that. I came into this class code for a reason. And what would that reason be? To show you all the steps. What happens in my mind when I see a question like this, like mostly fresh, because after a few months I cannot remember my own questions, and I look at this and try to problem solve that. Are we okay so far? Okay. And then we look at the next one. Question 5. And question 5 is just the same as I think the other one that we saw earlier. The only difference is what kind of arithmetic operation we perform here. So instead of a subtraction, this is a division. And question number 6, I think, is also the same as the question that we answered earlier, which was question number 4. And then question number 7 is different. Okay, so let's take a look at question number 7. Okay, the G function, as we talked about in the Aleph No module, scans diagonal lines to fill up a n by n space with sequential natural numbers, blah, 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 blah. Specifically for a specific k in n, xy in the two-dimensional space of n, Cartesian product with n, where x plus y equals to k are considered in the same diagonal line. Okay, so I think we got that part, right? Because this, as a constraint here, x plus y equals to k, as long as the k is the same, we are now talking about elements or pixels of the same diagonal line. So we're still remembering that part? Okay. So I even show you an example, like 3, 0, 2, 1, 1, 2, and 0, 3 are considered on one diagonal line, and so on. So you are given that P is an element of n times n, which means it is a two-dimensional coordinate, and that G of P is this number here. What is the coordinate Q, which is an element of the two-dimensional space, of one of the midpoints of the diagonal scan line that P is on? All right, so what is the coordinate PQ of the midpoint of that line? Okay, so what this is asking, oh, I need to move this window over, so give me a second. Okay, that stuff is from a previous class. I just have to give you a new fresh page. Oh, okay, wrong window. There we go. All right, so this is what this is asking is this. Okay. So you are given a particular point here, and this is P, where G of P is a particular value. So we'll just call it N right now. So the question is, if you draw a diagonal line, where's the midpoint of the diagonal line? That's what it's asking. Are we good so far? So, how would you figure this out? Now okay, so how do you approach a problem? Okay, you are given with certain things. Let me show you what you're given with, because this is problem solving. This is the process of problem solving, is to understand what you're given with and what we have talked about in the class, and then see what would be the first tool to apply, to try to answer this question. You are given with you're given with P, we don't know where it is, but we know that the natural number 56,938 is associated with that pixel. That is what you're given with. What we're trying to find is the midpoint on the diagonal line where P belongs. Okay, that is the question. That is what we're supposed to do. So what tool do you use when you are given a natural number? You just do not know which pixel is corresponding to that particular natural number. So we know G, right? We know G in one direction. If we try to figure out G of xy, it is x plus y times x plus y plus 1, the whole thing, divided by 2 plus y. We know how to compute g. But that's not what we're trying to do. We're trying to do what? The reverse of that. We already know what is x plus y times x plus y plus 1, the whole thing divided by 2 plus y. That turns out to be 56,938. 58. But what we want to know is, where is that? And from where that is, we want to figure out where's the midpoint of that. So what do? You're given the natural number, we want to find the coordinate. Yes?
Plug it into that function we used last time.
G,
Direct
G,
inverse.
inverse. Very good. Okay, so we apply G inverse, and then we apply G inverse to 56,958. That will give you a two-dimensional coordinate. It may not be the center, but all you have to do is to add the x and the y of that pixel, divided by 2. And if it turns out that x plus y is an odd number, then you have 2 middle pixels. If it turns out that it is an even number, if x plus y is an even number, then you have 1 single middle pixel. And that's why when I refer to the midpoint, I put the plural in parentheses, because you can end up with 2 quote-unquote middle pixels. But if you can find one of those 2 and write out the answer, it'll be fine. Okay, I'll still give you full credit, even though technically there are 2 midpoints. So where do you find G inverse? If this was an exam and you brought along everything, all the notes, all the modules and whatnot, how do you find G inverse? Where would you find it? Okay, which module? It is related to what? Does it relate to set notations? Does it relate to quantifiers? Does it relate to using quantifiers to express set notations? Does it relate to functions? Does it relate to the properties of functions? Or does it relate to aleph null? Aleph null, very good. Okay, so in the module that talks about aleph null, G is described. There's a definition of how to compute G knowing the coordinate of xy. But there's also G inverse, which is also defined. Now it does depend on an awkward function called W, which requires the use of square root. So that's why you might need a scientific calculator with you, because you might need to calculate the square root of something. But other than that, the module spells out exactly how to compute and solve for x and y when you're given the natural number. Okay? So I'm not going to do the math here because we are running out of time. I do want to cover all the questions today. And then on Wednesday, if someone wants to find out, okay, exactly what is the midpoint, I can go over that on Wednesday. But the approach is described today already. All right, so let's take a look at question number 8. Okay, so here's question number 8. And let's see, what is it asking? Using the G function introduced in the aleph null module, I even tell you it's aleph null, to compute the natural number corresponding to the coordinate of 3722 for conciseness k equals 2, G of 3722. So that would be pretty easy to compute, right? Because all you have to do is to say, okay, that's 37 plus 22 times 37 plus 22 plus 1, the whole thing divided by 2 plus 22. That does not even require a scientific calculator. A $1 calculator from the Dollar Tree can handle this. Not a problem. But that's not what I'm asking. Without using the G function again, explain how you can compute the G value of 3623. Right? But how do these two relate? By using K, how is K defined? This is how K is defined. 36 as a constant, 23 is a constant. Other constants, like 1, that seems to be a big clue to me, involving only additions, subtractions as operators. So that means you cannot use multiplication, you cannot use division, you cannot use square root, okay? You can only use addition, subtraction, You can only use the value of k, which is defined here, the constants 36, 23, and possibly 1, 2, 6, and whatever constant you want to use. How would you do that? How would you approach this problem first? You look at what is given to you, right? You are allowed to calculate the exact value of g of 3722, which is 1 pixel. And you're now asked to compute the g value of another pixel, which is 3623. You go like, how do we do that? First of all, what do you notice about 3722 versus 3623? Go ahead.
they're all the same line.
They're on the same diagonal line, right? Okay, that helps a little bit. But what is the relative positioning between these two pixels now that we know they are on the same diagonal line?
Pixel difference, like, down one, right one.
They're adjacent.
Yeah.
They're right next to each other. So what do we know about adjacent pixels on the same diagonal line when it comes down to the natural number assigned to that pixel, to those pixels? They're off by 1. Very good. Okay, so the only thing left for you to resolve is, are we adding 1 or are we subtracting 1?
You subtract one from x and then you add one to y.
No. You're close, you're close. So with a y value of 22, this g value is going to be 1 less compared to the g value over here, because the plus y is what makes the difference.
Yeah.
So that means we have to add 1. So the answer to this question is k plus 1. That's it, okay? So what this question is asking you is to see whether you recognize, oh, these two are on the same diagonal line, and therefore, and they're right next to each other. And therefore we know, if we know the value of this one is just off by a y offset of 1. So that means whatever this g value is, we just have to add 1 to find the other one. The last part of the question is a generalized question, which is basically just asking, hey, if I know k is the value of g of xy, and I want to figure out what is g of x minus 1, y plus 1, which is a generalized version of what scenario you're given with, how can I compute the g value of x minus 1, y plus 1? K plus 1 would be the answer. Is that okay?
Yeah.
Yeah, so this is really just testing whether you understand what the g values are representing, the general scheme of assigning the values to the pixels, the relationship between pixels on the same line, especially when they're adjacent to each other, and basic algebra. I mean, I have to say that it does involve a little bit of algebra, but you guys have all met the requirement of pre-calculus, which is a lot more than the algebra that we need here. All right, so that's it. That's the exam in spring 22. It is actual. This is not hypothetical. All right, so from this, okay, if you guys study and look at the questions again, and if you have any questions about the practice, no, I wouldn't say practice, I keep saying it, but it is not a practice exam. It is literally just the exam from spring 22. But if you do have anything that you want to ask or comment on, we can do that on Wednesday. All righty. So try to stay dry. See you guys in 2 days.
Seek question, role taking.
I did not take road.
No, вот это, I seek это, spelling. EP small window, там spelling, how spelling и там A and B.
You mean this text window? This one?
Нет, before это EP small window и там было spelling.
Spelling.
I see question. How spelling after after 1 minute disappear. I think maybe rolling. То есть, how I understand it, when you use role taking, you ask question.
I did not take role today.
No, okay,
Mm-hmm.
okay.
Yeah, I didn't have time to take role today, so I did not. Yep. So you're good.
Okay.
Yep. All right.
I have a question. Must have slipped my mind. Like, you have not announced the date for exam one.
Yes, I did.
Or did I blank out?
Yep, I did. It's next Monday, 1 week from today.
Oh, yeah, you did say that last class.
Not only that, but let me show you something. Not only that, but it is actually on the class calendar. Yeah, if you look at the calendar, it is there. Yep, but it's 1 week from today. Question?
This is about the CISP440.
Okay.
So, it's not, just to be clear, it's not that I wasn't paying attention in your class, it's that I'm kind of dealing with something, so.
Okay. That's all right. I can certainly understand that.
It's,
Yep.
It's hard, it's just hard to pay attention when you got other things going on, so.
Okay. Yeah, if you're concerned about, whether I feel disrespected or anything like that, there's no need to worry about that. So that is a non-concern, as long as you're not disturbing other people in class, it is not a concern.
Yeah,
Okay?
I didn't want to take too much of your time.
That's okay. But at the same time, I want to help, every person in the class. But to do that, you kind of need to ask questions about things that you do not fully understand. I cannot use a lot of class time to repeat what I have already taught before. So that is why it is important to review the material and basically dig up all the definitions, really kind of go through all the modules, dig up all the definitions, and kind of put them all in one place. So that way it's easier for you to visualize, how those definitions relate to each other. I'm not sure whether you have the time to do it or not. So what do you think?
Are you? Is that what you're saying?
Well, okay, let's just limit the scope to exam 1. So from the perspective of exam 1, it's going to be based on all the things that your labs. If you need to go, you can go. I mean, we can talk about this
No,
later.
The people picking me up are a bit late. So.
Oh, okay, I see. So, so from the perspective of exam 1, the labs that we have been doing, each one is basically trying to exercise a certain aspect of what we have learned in class.
Mm-hmm.
But it doesn't mean they're truly standalone. Like, the lab of today is not standalone because you kind of need to know how we computed the various roles, right? The X, Y, Q, T, and D, and what D is representing, and how we perform the multi-digit subtraction. So all of that stuff needs to be understood. And if you're having difficulty with the lab today, it is indicative that you may not be understanding some of the earlier concepts.
I figure if you fall behind in one thing, you will fall behind in all the other things.
Unfortunately, that is the case. Not because I wanted it to be the case,
Everything is intertwined.
but because everything is not just intertwined, it's layer by layer. So week one lays down one layer of the foundation. Week two, lays down something on top of what is in week one. So that means if you're not sure about some concept, like from today, you really have to kind of trace all the way back. Like, okay, I'm not really sure what is B, the B function. Okay, then you have to reread the binary subtraction module and see if you remember, see if you can understand what B is trying to do. What is the purpose of the B function, and how it is derived, and how it is what it looks like in binary. If that becomes an issue, then you have to go back to the binary addition, because a lot of the concepts in binary subtraction borrows from, no pun intended, from binary addition. And then binary addition, is kind of long, especially the carry look ahead mechanism. So, so you basically have to read and see if you understand the full concept. And one thing that I think people do is they read a sentence, they go like, okay, I understand every single word of that sentence, I'm good. No. Some of those words have very special meanings. Like, okay, what is the borrow? What is the t bit of position I plus 1? How do we compute that? It's b of xi yi, or b of qi ki. But then you have to understand why. Why is that the or between those two? Because
it's easy to listen, but not to conceptualize what you're taking.
Right, exactly. I know that. So that's why it is important.